Before we start, I'm going to share with you the objectives of this activity. The first one, we can design an IPv4 network subnetting scheme. Next, we can configure the devices. After that, we can test and troubleshoot the network. For the background, in this activity, based on the topology given after this, we will subnet the customer network into multiple subnets. The subnet scheme should be based on the number of host computers required in each subnet, as well as other network considerations like future network host expansions. After we have created a subnetting scheme and completed the table by filling in the missing host and interface IP addresses, we will configure the host PCs, switches, and router interfaces. After the network devices and host PCs have been configured, we will use the ping command to test for the network connectivity.
Part 1. Subnet the assigned network. Create a subnetting scheme that meets the required number of subnets and required number of host addresses.
So, here is the topology diagram given for the activity. Let's take a look at the diagram. As we can see, based on the diagram, the LAN A connect to the interface and it is also state the 50 hosts. Based on the preference in the Cisco packet tracer, it shown that the interface is gigabit 0/0. The second subnet is LAN B, which also connect to customer router with gigabit 0/1 with 40 hosts. Next, for the instructions, the scenario given, you are a network technician assigned to install a new network for a customer. You must create multiple subnets out of the 192.168.0.0/24 network address space to meet the following requirements. So, based on the topology diagram, it's shown 3 requirements, which is the first subnet is the LAN A network. We need a minimum of 50 host IP addresses. The second one, the second subnet is the LAN B network. We need a minimum of 40 host IP addresses. The last one, we also need at least 2 additional unused subnets for future network expansions. Before we answer the question, the note given, variable length subnet mask will not be used. All the device subnet masks should be the same length. So, let's read the instruction first. Answer the following question to help create a subnetting scheme that meets the state network requirements. The first question, how many host addresses are needed in the largest required subnet? As we can see in the previous slide, it states that minimum of the host addresses for first subnet are 50 hosts. So, the answer will be 50. The next question, what is the minimum number of subnets required? Based on the requirements, the first and second requirement states that we need 50 and 40 host IP address, and so that we already have 2 subnets. And then, the last requirement, we also need at least 2 additional unused subnets. So total of the required are 4 subnets. The answer should be 4. The next question, the network that you are tasked to subnet is 192.168.0.0/24. What is the /24 subnet mask in binary? So it is prefix /24. And as we know, the subnet mask will be 255.255.255.0. And we need to convert to binary number, so 255 will be 111.111.111, and another 255, So it will be .111.111.111, and next 255. So it will be .111.111.111, and 0. That means we need to write 8 times 0, so it will be 000000000, because in IP address each of it represent 8 bits, so that's why we write 0 8 times. So we go to the next question. The subnet mask is made up of two portions, the network portion and the host portion. This is represented in the binary by the ones that the zeros in the subnet mask. So the question is, in the network mask, what do the ones represent? So basically, ones represent the network portion. The next question, in the network mask, what do 0 represent? So the 0 represents the host portion.
Okay, for question 1F, given each of the possible subnet masks depicted in the following binary format, how many subnets and how many hosts are created in each example? So for the first one, which is prefix 25, the dotted decimal subnet mask is equivalent to 255.255.255.128, and for the number of subnet is 2 to the power of 1, which is 2. So the 1 is we take from the 1 borrowed by the network ID, where the number of hosts is 2 to the power of 7 minus by 2 is equal to 128 minus by 2 is equal to 126 hosts per subnet. So the 7 here represent the 7 0 in the host ID, and we minus by 2 because the two other hosts we cannot use that host, so the usable is only 126. So for next one, for prefix 26, the dotted decimal subnet mask is equivalent to 255.255.255.192, and the number of subnet is 2 to the power of 4, which is 4. Here we can see the borrowed one is 2, so we just have to 2 to the power of 2, which is 4, and the number of hosts is 2 to the power of 6 minus by 2, which is 64 minus by 2, which is 62 hosts. We move on to prefix 27. The dotted decimal subnet mask is equivalent to 255.255.255.224, and the number of subnet is 2 to the power of 3, which is equal to 8, and the number of hosts is 2 to the power of 5 minus by 2, which is 32 minus by 32 minus by 2, which is equal to 30 hosts per subnet. And for prefix 28, the dotted decimal subnet mask is equivalent to 255.255.255.240, and the number of subnet is 2 to the power of 4, which is 16. As you can see from the question, there is 4 ones borrowed by the network ID, and the number of hosts is 2 to the power of 4 minus 2, which is 16 minus 2 equal to 14 hosts per subnet. For prefix 29, the dotted decimal subnet mask is equivalent to 255.255.255.248, and the number of subnet is 2 to the power of 5, which is 32, and the number of hosts is 2 to the power of 3 minus 2, which is 8 minus 2 equal to 6 hosts. And for prefix 30, the dotted decimal subnet mask is equivalent to 255.255.255.2 255.252, and the number of subnet is 2 to the power of 6, which is 64, and the number of hosts is 2 to the power of 2 minus by 2, which is 4 minus 2, and equal to 2 hosts per subnet. We move on to question G. It says, considering your answers above, which subnet mask meets the required number of minimum host addresses, which is 50 hosts. So we can see that the answer is prefix 25, which has 126 hosts, and prefix 26, which has 62 hosts per subnet. For question H, considering your answers above, which subnet mask meets the minimum number of subnets required, which is 2 subnets? The answer is prefix 26, which has 4 subnets, prefix 27, which has 8, prefix 28, which has 16 subnets, and last but not least, prefix 29, which has 32 subnets. Considering your answers above, which subnet mask meets both the required minimum number of hosts, 50 hosts, and the minimum number of subnets required, which is 2 subnets? As we can see from both question, prefix 26 meets the requirement number of minimum hosts, which is 62 more than the required host, which is 50, and for the subnet, prefix 26 has 4 subnets, more than the 2 subnets required in the question. So for question J, when you have determined which subnet mask meets all of the stated network requirements, derive each of the subnets. List the subnets from first to last in the table. Remember that the first subnet is 192.168.0.0 with the chosen subnet mask. So we have chosen prefix 26 because it meets both the requirement. So first, the subnet mask would be 255.255.255.192. So we can fill all the table with the subnet mask, and the number of hosts for this subnet mask is 64, but the usable is only 62. So it mentioned that the first subnet mask is 192.168.0.0, so we put it in the first row. So for the second subnet address, we just have to add or plus with 64 because it has 64 hosts in the subnet. So we can add at the back, and for the third one, we also just have to add with 64, which is equal to 192.168.0.128, and the last subnet address is also, we can add another 64, which is 192.168.0.192. So next, we need to fill the addressing table here. So basically, the yellow cells is actually empty, so we have to fill this one. So first, assign the first subnet to LAN A. Use the first host address for the customer router interface connected to LAN A switch. So it asks us to use the first host address. Okay, as we can see from the previous table, the first subnet address is 192.168.0.0. So we cannot use the first one because it is reserved for the network address, as we can see here. So like I said before, we have 64 hosts in the subnet, but we can only use 62 hosts because the first host will be the network address, and the last one will be the broadcast address. So here we can see that the first usable IP address is 192.168.0.1, and the last usable is 192.168.0.62. so we can only use from 1 to 62. Okay, so it says that we have to use the first host address. So here we can see that I use .0.1 from the first usable IP address, and the subnet mask will be 255.255.255.192 because the prefix 26 meets the requirement. So use the second host address for LAN A switch. Make sure to assign a default gateway address for the switch. So for LAN A switch, it says that we have to use the second host address. So after the first usable IP address, which is 0.1, we can use 0.2, and the subnet mask is still the same because we use the same prefix, and the default gateway would be 192.168.0.1 because it is connected to the gigabit 0 interface. So next, use the last host address for PCA. Make sure to assign a default gateway address for the PC. So for PCA, here we can see it says that we have to use the last address. So the last usable address is 192.168.0.62 and not .63 because this is reserved for broadcast address. So we use .0.62 here, and the subnet mask is still the same, 255.255.255.192, and the default gateway is the same with LAN A switch, which is 192.168.0.1. Okay, next we go to assign the second subnet to LAN B. Use the first host address for the customer router interface connected to LAN B switch. So we have used this the subnet address. So next we will be using 192.168.0.64 subnet address, and it says we have to use the first host address. So we cannot use 0.64 because it is reserved for network address. So we have to use the first usable IP, which is 0.65. As you can see here, for gigabit 1 we use 0.65, and the subnet mask is the same with previous, which is 255.255.255.192. And for the second one, use the second host address for LAN B switch. Make sure to assign a default gateway address for the switch. So for LAN B switch, it says we have to use the second host address. It is the same with the LAN A switch, as we have used 65, so the next usable IP address would be 66, and the subnet mask is still the same, and the default gateway would be 192.168.0.65 as it is connected to gigabit 1. And last but not least, use the last host address for PCB. Make sure to assign a default gateway address for the PC. Okay, for PCB it says that we have to use the last host address. So the last usable is 192.168.0.126, and the subnet mask is still the same, and the default gateway would be 192.168.0.65.
So next, I will continue for part 2, which is configure the devices. Configure basic settings on the PCs, switches, and router. Refer to addressing table for device names and address information. In this part, we have 3 steps, which is step 1, 2, and 3.
In the figure of our packet tracer, subnet, and IPv4 network, we have PCA and PCB, and also ISP workstation. We use the end device, which is PC. Next, for the switches LAN A, LAN B, and ISP switch, we use type switch, which is 2960 switch.
Then for the router, customer router and ISP router, we use type 2901 router. For the ISP server, we use the end device, which is server. Lastly, for the connection, from PCB to LAN B, we use we use Cooper straight through. But for customer router to ISP router, we use connection, which is serial DTE. First, for step 1, which is configure customer router. A. Set the enable secret password on customer router to class 123. B. Set the console login password to Cisco 123. C. Configure customer router as the name for the router. D. Configure the Gigabyte Ethernet 00 and Gigabyte Ethernet 01 interfaces with IP addresses and subnet masks, and then enable them. E. Save the running configuration to the startup configuration file. This is our full addressing table. For step 1, we only use customer router addressing table. Hence, this is our customer router addressing table that we will refer after this. For the step 1, we need to click the customer router of our packet tracer. Then we go to CLI, click enter, and now we will start with step 1A, which is set the enable secret password on customer router to class 123. Type enable and then configure term, enter, type enable secret class 123. Okay, next for step 1B, which is set the console login password to Cisco 123. Enter, then type console align console 0. Next, click password Cisco 123. Enter, then type login. Then type exit. And now we will do step 1C, configure customer router as the hostname for the router. So after that, for the hostname, which is customer router, then next we will continue for step 1D. Configure the Gigabyte Ethernet 00 and Gigabyte Ethernet 01 interfaces with IP addresses and subnet masks, and then enable them. Enter, then type line console again 0. Click enter, then type the interface of Gigabyte Ethernet 00. As what I said just now, we need to refer the customer router addressing table to do step 1D. So for the device customer router, the interface for Gigabit Ethernet 00, the IP address is 192.168.0.1 and the subnet mask is 255.255.255.192. Then the IP address, we need to refer to the addressing table, which is 192.168.0.1, and for the subnet 255.192. Then enter, click shutdown. Then for the interface Gigabyte Ethernet 01, type interface Gigabyte Ethernet 01, click enter. Next, the customer router interface of Gigabit Ethernet 01, the IP address is 192.168.0 and 65. The subnet mask same as the interface of Gigabit Ethernet 00, which is 255.255.255 and 192. And the IP address 192.168.0.65. Then for the subnet mask 255.255.255.192. Then click enter, type shutdown. Then click enter again, type end. Last but not least, for step 1, E, save the running configuration to the startup configuration file. We need to type it in our CLI. For the E question, we need to type copy running configure startup configure. Copy running configure start. Then click enter 3 times. So now I will pass it to my friend to continue for step 2 and 3.
Okay, so now for step 2, configure the 2 customer LAN switches. Configure the IP addresses on interface VLAN 1 on 2 customer LAN switches. Make sure to configure the correct default gateway on each switch. So we go to LAN A, click on CLI and press enter. We type in enable, then we type in config terminal, and after that we key in the IP address from the addressing table, but before that we have to access the interface of VLAN 1 and then key in the IP based on the addressing table for LAN A switch. So 192.168.0.2 and then 255.255.255.192 and press enter. No shutdown to access the interface, and after that we type exit, and then we have to input the default gateway into LAN A. So IP default gateway 192.168.0.1, and after that we have to input the host name. Make sure it's case sensitive. LAN A, enter. Okay, now for LAN B, same process as LAN A. So enable config terminal, interface VLAN 1, IP address based on the addressing table for LAN B switch. So 192.168.0.66 then 255.255.255.192, and press enter. No shutdown. Okay, after that, exit, and then you have to input the default gateway for LAN B switch. So IP default gateway 192.168.0.65, and then host name for LAN B, make sure it's the same as here, it's case sensitive, LAN B. Okay, after that, step 3, configure the PC interfaces. Configure the IP address, subnet mask and default gateway settings on PCA and PCB. So PCA, we're going to desktop, IP configuration, and based on the addressing table, PCA, just simply input the IP address, subnet mask and default gateway. So IP address 192.168.0.62. For the subnet mask 192, and for the default gateway 192.168.0.1. Okay, that's for PCA. Now for PCB, the same process, IP config, so key in the PCB IP address, subnet mask and default gateway. So 192.168.0.126, and then for the subnet mask, simply change the 0 to 192, and default gateway 192.168.0.65. Okay, so now part 3, test and troubleshoot the network. In part 3, you will use the ping command to test network connectivity, provide proofs, determine if PCA can communicate with its default gateway. So PCA, desktop, command prompt, ipconfig. As you can see, this is the default gateway. So ping its own default gateway 168.0.1. Do we have a ping? Oh, okay, successful. So do you get a reply? Yes. Then determine if PCB can communicate with default gateway. So PCB, same process as PCA, command prompt, ipconfig. Here is the default gateway. So we have to ping its own default gateway 0.65. Okay, successful. So do you get a reply? Yes. And lastly, determine if PCA can communicate with PCB. Do you get a reply? So let's try PCA, command prompt, ping with PCB. So PCB is 65, so 192.168.0.65. Okay, we got a ping. So do you get a reply? Yes. So that's all for me. Thank you.